Well, class, welcome back. Let's begin looking at congruent figures. Now, this lesson is a foundation for lessons that are to come, so we have to have a good understanding of what congruent figures are before we're able to move on. Now, just a couple of quick things that we need to talk about. One is congruent figures have the same size and shape, so they're exactly the same. The only thing that happens is when we have two congruent figures, we can move one so that it fits exactly on the other. So all parts match up exactly. Congruent polygons have congruent corresponding parts, meaning their matching sides and angles are the same. Now, we're going to be naming some polygons and figures here in a little bit, but when we name a polygon and we know that they are congruent, we always list the corresponding vertices in the same order. So, here we go. Naming congruent parts. Well, first of all, I really and truly don't even need to have these figures. If I told you that triangle ABC is congruent to triangle XYZ, this congruent statement would be enough. That's all we would need to know. Because when we have congruent figures, in this case congruent triangles, the corresponding parts of a congruent statement are also your corresponding parts in the figures. What do we mean? Well, let's look at the letter A. A is in the first position, X is in the first position. Notice that A and X would match up. So when I am listing, I have angle A is congruent to angle X. B is in the second position, Y, so B is congruent to Y. So angle B congruent to angle Y. And C and Z are in the last position, so angle C is congruent to angle Z. We can mark that here as well. So that gives our angles. Now let's look at what are our other parts. Well, polygons, we have either angles or sides. We can do that the same way. Notice that AB, first two letters, XY, first two letters. So AB corresponds to XY. So AB is a segment. It is congruent to XY. We can then look at the second two letters of BC, which is this segment right here, and it corresponds to YZ, second two letters. So BC is congruent to YZ. And the very last one we have this side of AC and this side of XZ. Notice that I said AC and XZ. AC is congruent to XZ. We talked about naming parts in order a while ago, but if you didn't see that it was AC and you said CA, well then CA is congruent to ZX. Oops. Let's clean that up. At ZX. So our order matters when naming congruent parts and corresponding parts in this case. So, naming congruent parts, understand that our parts have to match up. We can simply take a congruent statement and just use the position of the letters. Doesn't matter if there's 3 or if there's 5. As long as our order is here, that is all we have to have in order to list our corresponding parts. Next, let's look at finding congruent triangles. We want to decide whether the triangles are congruent, and we need to justify our statements. Remember that justifying, we have to give an explanation for the reason why we say. We can't just say because. We have to justify our reasons. Now, let's look at it. We want to determine or find these two triangles to be congruent. Let's start listing all the parts that we know. Now, if we look at it, we see that we have side RT and side VT are the same. How do we know? Because they have those one single markings. So simply RT is congruent to VT, and why is that? That is a given, because it's marked. We don't say because it's marked, but it's a given in this case. We also have another given. We have angle R is congruent to angle V. Notice they're single arcs. So both of these are givens. What else do we have? Well, angle S is congruent to angle U, because they're both right angles, and all right angles are congruent. True statement. So we can simplify the writing if we need to. So now let's start looking at our parts. We are given that RS and VU are both 3. So if they have the same measure, then they are congruent parts. So RS is congruent to VU because they both equal 3. So in this case, my justification would be RS equals 3, which also equals VU. How does that work? RS equals 3, VU equals 3. We also have that ST is congruent to UT. Why? Well, ST equals 4, which also equals UT. Now, let's count these. We have 1, 2, 3, 4, 5. So we're missing one. Triangle each has 6 parts, 3 angles and 3 sides. We only have 1, 2, 3 sides, 2 angles. So what's the third angle that we're looking at? Notice that in this intersection at T, these two lines are supposed to be here. Notice that at this intersection we have, remember, that bow tie effect. And when we have that effect, we call those vertical angles. So I know that angle, and I'm going to call it RTS. Angle RTS is congruent to angle VTU. VTU. Notice the order that I went. I went from the single mark to my vertical to the right angle, the single marked angle, vertical to my right angle. And why? Vertical angles. So we have just justified all 6 parts of the triangles being congruent to each other. So if we can state all 6 parts of the triangles to be congruent, we can now write a congruent statement. Well, what is congruent? Triangle RTS is congruent to triangle VTU. We've showed all parts and we've justified all parts, so now we can then state a congruence statement of the triangles. Now, just a little bit of information here that we need to remember. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are congruent. So we have here a diagram. We have that angle R is marked and showing that it's congruent to X. Angle T is congruent to Y. So through this theorem, we're stating that angle S would be congruent to angle W. Now we can prove this algebraically by, if we looked at the measures of these 2 angles and the measures of these 2. Well, if they're the same, say that we have 45-degree angle here, can't fit it in there. This one's 45. We say that this angle here is a 35-degree angle. And this angle here is 35-degree angle. Now remember always, diagram is not to scale. We can then show by adding 45 and 35, we get 80. So that means that this angle would equal 100 degrees. Well, if we take this triangle, 45 and 35, it's also 80. By adding, we see that this angle here is 100 degrees. So by the fact that the sum of the angles of a triangle equal 180 degrees, we can then prove that. So since it's already proven, we no longer have to prove it. We can always now use it.